Hi everyone, here I am with a new topic called Atomic Absorption Spectroscopy. First is definition and next is principle and next is instrumentation and next is advantages and applications. First is definition. Atomic absorption spectroscopy is a technique to determine the concentration of a particular element. Atomic absorption spectroscopy is a technique to determine the concentration of a particular element, and it occurs due to the absorption of energy by ground state atoms in a gaseous state and forms the atomic absorption spectroscopy. Means the unexcited atoms, which again retains its ground state, there is an radiations, and these radiations are passed through the grating element and again to the detector, and this is how the atomic absorption spectroscopy works, and it was discovered in the year 1802. Next is on what basis the atomic absorption spectroscopy works, that is, the amount of light absorbed by the atom is directly proportional to the density of atoms. That is, the light absorbed by the atoms is directly proportional to the density of the atoms, is nothing but the concentration of element, and this light absorbed by the atoms at a particular frequency is given by constant into n into f, where constant is equals to pi e square by mc, where all the terms are known, and n is the number of the atoms which absorbs the radiation, the number of atoms which absorbs the radiation, and f is the oscillatory strength or the capability of each atom to absorb the radiation, or we can say to absorb the light energy. And next is when a light is passed through the flame, then the light is here the flame contains the atoms which are in ground state, and these atoms are in gaseous form, and these absorbs the radiation, and the unabsorbed radiations are transmitted to the prism, and this prism converts these radiation into spectrum, and this spectrum is detected by the detector. This is the outer mechanism, and the inner mechanism is here in the second figure. That is, you can observe here that the light of specific wavelength can be converted into two mechanisms. That is, one is absorption and another one is emission. And here atomic vapor in a ground state and atomic vapor in excited state. The atomic vapor in excited state and atomic vapor in ground state emit the radiation. But here, as we know that the atomic absorption spectroscopy, the atomic vapor in the ground state absorb the radiation, and the radiations which are emitted by the unexcited atoms are taken to be the reference, and these unexcited atoms producing the radiations are converted into spectrum, and then it is sent to the detector. So here there are two mechanisms, means this principle is common for both atomic absorption spectroscopy and flame emission spectroscopy. So next is, let us see what is the inner mechanism going in the atomic absorption spectroscopy. And see here, you can observe here there is a ground state atom, a ground state, and these two are the excited state. So when a light, or we can say when a photon is incident on an electron or an atom in the ground state, this is just a reference for how the ground state atoms absorbs the energy. And here you can see how the photons are absorbed by the atoms, and when it is absorbed by the atom, there is a transition. Since these are unstable, the excited electron is unstable, so they will fall again to the ground state, or it retains its mean position, or we can say, so there is an emission. So this is said to be the atomic absorption spectroscopy. When it is due to the unexcited atoms. This is how we can see through eyes. So here I can give an example. For example, if you think a boy is in school and you imagine that a boy is in school and he is hungry and he wants to go to his home, but he meets his aunt and there he eats food and he returns to the school. So therefore he has gained the energy, but he returns to the school. This is in the first case. This is due to the atomic absorption spectroscopy, you think. Similar way, when the atoms are excited to the or we can say when atom is transmitted to the excited state, but due to the unstable it regains its mean position, then there is an emission, or we can say then there is a radiation due to the unexcited atoms, and these radiations are sent to the prism and again it is sent to the detector. This is how the in first case, that is atomic absorption spectrum, takes place. But when a boy is hungry, he directly goes to the home and he eats their food and he will be there only. It is in the case of flame emission spectroscopy, or we can say when the atoms are excited and it will be in excited state only, and there the radiations are emitted, and due to the excitation of atom the radiations are emitted, and these radiations are said to be the flame emission spectroscopy. So this is how the flame emission spectroscopy and atomic absorption spectroscopy is differentiated. And the atomic absorption spectroscopy contains various components as shown in figure. You can see here, this is the halo cathode lamp, and where the cathode rays are produced, or you can say the elements of a cathode rays are produced, and this cathode rays are or we can say incident on the cathode rays are incident on the flame, and here the gas, or we can say that the chemical, or we can say element which we have to determine the concentration, or we can say density of atoms, it is aspirated from capillary tube, or we can say it is taken from capillary tube, then it is by the process of nebulization, that is the conversion of water droplets into small droplets, or we can say it is converted, or we can say the sample is converted into droplets, that is called as a nebulization. Then the dissociation takes place, then the further process takes place, and finally it is converted into the gaseous form, that is in the ground state. The ground state atoms are in the gaseous form where the absorption takes place, and the unabsorbed radiation, or we can say the radiations emitted by the unexcited atoms, is sent to the monochromator and then to the photomultiplier, where it is increased, or we can say where it is amplified, or we can say we can get accurate value by photomultiplier, and then it is amplified by using the amplifier, and then the readout system, or we can say the digital display or a computer, which can be the graph, or we can say the CRO, the cathode ray oscilloscopy, we can say. There the displacement is directly proportional to the input voltage. And here the study of spectrum, how the readout system takes the values of the absorption, or we can say absorbance of the atoms. Here is the picture, or we can say animation. See here, the absorption of energy by atoms is given by the dark lines, that is dark black color, and the emissions is given by color lines. This is how the spectral lines are observed, and this is how the spectrum is studied. And next is advantages and applications. First is the atomic absorption spectroscopy is independent of temperature. The main advantage of atomic absorption spectroscopy is that it is independent of temperature. So we can use means it is reliable. It is very reliable for any element. So, and next is atomic absorption spectroscopy is independent of wavelength of absorption. As we know that there is no involvement of wavelength term in the in the principle as we have observed. And next is these are the two main advantages over flame emission spectroscopy. Whereas in flame emission spectroscopy, the excited atoms, means the atoms which are excited in state, these excited atoms depends upon the temperature, whereas unexcited atoms doesn't depend on the temperature. So these are the main two advantages over the flame emission spectroscopy. And next is applications, that is to identify substance and to determine its concentration, and to study the composition of stars, and to study the concentration of lead in petrol. How to first one application to study a substance and to determine its concentration. How can it be done? Means due to the principle. The principle itself says that the absorption of light is directly proportional to the density of atoms. And next is to study the composition of stars. When a light is emitted by the planets or stars, it must pass through the atmosphere, right? Then the atmosphere contains the gas molecules, and these gas molecules absorbs the light emitted by the planets and stars, and this gives the another spectra, means absorbed spectra, and this spectra is studied by the atomic absorption spectroscopy. And this is how the composition of stars is studied, and similarly the concentration of lead in petrol. Thank you.